This video covers Chapter 12, Introduction to Probability. So what we're going to cover in this class is the idea of probability, the search for randomness, probability models, probability rules, those are really important, finite probability models, and continuous probability models, as well as random variables and personal probability. So what is probability? So probability is is the likelihood of an event occurring. Chance behavior is unpredictable in the short run, but it has a regular and predictable pattern in the long run. So for example, if we were flipping a coin and you flipped it once, it's 100% heads, right? It may be, or 100% tails. You flip it twice, well, you could still get two tails, two heads, but if you do that test like hundreds and hundreds of times, it's going to end up being like 50-50, half the time. That's kind of like a good gut instinct to go back to is, say, a coin flip. So we call a phenomenon random if the individual outcomes are uncertain, but there is nonetheless a regular distribution, not necessarily normal, of outcomes in a large number of repetitions. So the probability of any outcome of a random phenomenon is the proportion of times the outcome would occur in a very long series of repetitions, right? So let's pretend we're flipping a coin, right? The odds of getting the heads is half the time, tails would be half the time. So here we have the proportion of heads after one coin flip. 5 coin flips, it's not quite half. 10, 50, 100s, 500,000. You see it gets closer and closer to the true probability of getting heads, the theoretical probability. That's different than an experimental probability, which we'll talk about as well. So here I have a probability model. So probability models are descriptions of chance behavior, and they contain two parts, a list of possible outcomes and the probability for each outcome. So the sample space of a random phenomenon is the set of all possible outcomes. So if I have a probability model for, like, flipping a coin, my sample space is heads and tails, right? That's all I can get. An event is an outcome or a set of outcomes of a random phenomenon. So an event would be a subset of the sample space. So if my sample space is all possible outcomes, one possible outcome could be heads. That would be an event. And a probability model is a mathematical description of a random phenomenon, and it consists of two parts, a sample space and a way of assigning probabilities to events, right? So the probability of heads is 1/2, and the probability of tails, if I was just flipping a coin, is, 1/2. So let's take a look at another example that doesn't involve flipping a coin, one that's a little more complicated. So let's give a probability model for the chance process of rolling two fair six-sided dice, one that is red and one that is green. That way we can tell them apart. So here's the entire sample space, right? I could roll a 1 and a 1, or a 1 and a 2, or a 1 and a 3, and a 1 and a 4, 5, 6, right? Because it's a six-sided dice. It's important to note that we say fair, fair meaning the dice are not like weighted, or maybe they have two of the same number on one side, right? We want them to be fair dice, like dice that's used in the casino, like nice dice. So here you see my green is going 1 to 6, and here we have my red going down 1 to 6 in every column, right? So this is all possible outcomes. So there are 36 total outcomes, right? We create a 6x6 square. And since the dice are fair, each outcome is equally likely. Each outcome has the probability of 1/36, as long as we're like distinguishing between these two dice, right? So probably of getting a 6 on red and a 6 on green is 1/36, right? But it'd be a little bit different if we just wanted, what's the probability of getting a sum of 6, right? That'd be a little different because where there are sums are 6. Our sums are 6. Let's switch to green. Here, 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 here. So that would be probably to get a sum of 6 would be 5 out of 36, which is something they'll typically have you look for as well as the probability of sums when it comes to working with dice. So let's get introduced into some probability rules. So first part, probability rules. A probability is any number between 0 and 1. Any proportion is a number between 0 and 1. So any probability is also a proportion between 0 and 1. 0 means there's no way that could possibly occur. 1 means there's a 100% chance of it occurring. 2, all possible outcomes together must have a probability of 1. Because some outcomes must occur on every trial and some outcomes must not occur, the sum of all possible outcomes is going to be exactly 1. So for example, if I had the probability of heads plus the probability of tails, that would be 100%. If two events have no outcomes in common, the probability of one or the other occurs is the sum of their individual probabilities, right? So if two events have no outcome in common, then the probability that one or the other occurs is the sum of their individual probabilities. So the probability that an event does not occur is 1 minus the probability that the event does occur. So if I wanted the probability of tails, that'd be 1 minus the probability of heads, which is 1/2. We see that that's hold true. So the probability of all events have to add up to 1. Second part of our probability rules before we do an example, here's our formal language. So we say the probability of any event A, we typically use capital letters to signify events, certifies that 0 is less than or equal to the probability of A is less than or equal to 1, right? It has to be in between 0 and 1. 2, if S is our sample space, the probability of the sample space, so everything possible that could occur added together, is going to be 1. Two events are called disjoint if they have no outcomes in common and thus can never occur together. So if they're disjoint, then the probability of them both occurring could be added them together. So quick side note, so let's say I have 1 dice. The probability of rolling a 6 is 1 out of 6 because there's 6 sides. The probability of rolling a 3 is 1/6. So the probability of rolling a 3 or a 6 would be 1/6 plus 1/6, which would be 2/3, right? So we can add those probabilities together. This is called the addition rule for disjoint events. Rule 4, for any event, the probability that A does not occur equals 1 minus the probability of A. Which we already stated was a good way to find. So the probability I don't roll a 6 is 1 minus the probability I roll a 6, so 1 minus 1/6, which would be 5/6. So we'll start this next video with an example.